Hey everyone, and welcome to another XIM tutorial. Today, I want to explain you what the XIM ballistic curve is, and how you can use it to increase your gaming performance. This tutorial will work with all current XIMs, such as the XIM Apex and the XIM 4. This video is the first of two tutorial parts. It focuses on the concept of the ballistic curve, and will explain everything you need to know to understand curves, and to also create your own one. The second part will cover a lot of popular XIM curves and will explain their purposes in more detail. At the end of this video I will show a few additional easy tricks that you can use to quickly identify what a curve does. The smart translator technology of your XIM makes sure that your mouse movements have no mouse acceleration at all. As of now, it is the only device on the market that can completely eliminate acceleration on console games. This means that when you play your favorite games, your mouse movements will have a true one-to-one translation with your crosshair in-game, just like on PC. Now, the ballistic curve is basically a tool that allows you to reintroduce a fully customizable mouse acceleration. This can be beneficial in some games, or game scenarios. I will show you several examples in the second ballistic curve tutorial part. But before I explain you how ballistic curves work, let's answer the question, what is mouse acceleration first. Mouse acceleration essentially increases, or decreases your mouse sensitivity based on how fast you move your mouse. Without acceleration, if you move your mouse twice as fast, your in-game crosshair will also move twice as fast. There is a linear scaling between the speed you move your mouse, and the crosshair movement it results in. Move your mouse half as fast, and your in-game crosshair will also only move half as fast. With acceleration, however, if you move your mouse twice as fast, your in-game crosshair will move 3 times faster, or even 5 times faster. It all depends on how much acceleration you are using. With negative acceleration, if you move your mouse half as fast, your in-game crosshair will move at 1/3, or even 1/5 of the speed. In general, there is no more linear scaling, which makes it difficult to build up muscle memory. The whole concept of positive and negative mouse acceleration will be easier to understand when we look at the XIM ballistic curve. So, let's start with the second topic of this video: how does the ballistic curve work? Here you can see the XIM ballistic curve with its linear default curve. At the bottom, you have the x-axis. This axis represents the speed you move your mouse on the mousepad. On the very right side of the axis, you have the point where you move your mouse as fast as you can. On the very left side, you don't move your mouse on the mousepad at all. The y-axis on the left of your ballistic curve displays the speed of your in-game crosshair movement. At the bottom of the axis, there is no in-game crosshair movement at all. At the very top, your in-game crosshair is moving with the maximum turn speed of the game. The graph in the middle of the ballistic curve will control the behavior between the two axes, or in other words, between your mouse movements and your in-game crosshair speed. Depending on how you draw the graph, you will add positive acceleration, negative acceleration, or no acceleration to your mouse movements. Let's look at some examples for a better understanding. Here is a picture of the default curve with a coordinate grid placed on top of it. I have also changed the names of the axes to make it a little bit clearer. Now, when you want to analyze the effect of a ballistic curve, the best way to do this is to compare several x values with their corresponding y values. For example, I will now pick the x value 3. The next step is to draw a vertical line from this point upwards until I hit the curve itself. From there, I will move horizontally to the left until I hit the y-axis. After that, I will compare my x-axis start point with the end point of the y-axis. In this example, I started at 3, and ended up at 3 again. This means that when I move my mouse on the mousepad with a speed of 30%, I will get an in-game crosshair movement speed of 30%. When I do this again with the x-axis value 6, I will get an y value of 6 again. In other words, when I move my mouse with 60% speed on the mousepad, which is twice as fast as in the example before, I end up with an in-game crosshair speed of 60%, which is also twice as fast as the 30% from before. This applies to all other points of the graph too. Their x and y values are always the same. This means that the default ballistic curve is linear, and doesn't add any mouse acceleration at all. No matter how fast, or slow, you move the mouse, the in-game crosshair will always have the same corresponding speed. This is what we call a true one-to-one aim translation. Your x-axis value is always the same as your y-axis value, so there is no acceleration at all. However, this will change once we add acceleration. Let's look at the following example which has positive mouse acceleration. One thing that directly stands out is that this curve is above the linear default graph for all x values. I start again by picking a specific x-axis value to find out what its corresponding y-axis value is. This time, I will go with the x-axis value 2. When I move from there vertically up until I hit the curve, and then move horizontally to the left, I end up with an y value of around 3. If I move my mouse with a speed of 20% on the mousepad, the crosshair will turn with a speed of around 30% in the game. But before we analyze what this exactly means, let's check a few more values. The x value 5 results in a y value of around 7, as you can see here. And when I do the same for the x value 7, I receive a y value of 10. In all three examples the acceleration is always identical, because the gradient of this curve section doesn't change and is constantly above 1. All y values are basically their x values multiplied with around 1.43. For example, 7 multiplied with 1.43 is exactly 10. So all that the curve is doing so far is to multiply my mouse movements with 1.43, which is exactly the same as if I would multiply my XIM sensitivity with 1.43 and no ballistic curve is used. Since the ratio of 1.43 doesn't change between the x value of 0 and the x value of 7, the mouse movements are still perfectly linear and there is no acceleration happening at all. This changes however when we look at the x values that are greater than 7. The x values of 8, 9 and 10 will all result in one and the same y value, which is 10. This means that when I move the mouse on the mousepad faster than 70%, I will automatically move my crosshair with 100% of the maximum turn speed in the game. It doesn't matter if I move the mouse with 71% or 99%, the corresponding crosshair movement speed will always be 100%. So, the conclusion is that this curve does exactly two things. First, it multiplies my base sensitivity by 1.43, and keeps my mouse movements linear like on PC. The second thing it does is to allow me to reach the maximum turn speed of the game much faster. I no longer have to move my mouse with 100% speed on the mousepad to hit the maximum turn speed. Thanks to this curve I already reach it with any speed that is above 70%. Let's look at an example curve with negative acceleration. This time it's the entire opposite. The following curve is below the linear default graph on all x values. First, I will analyze all x values until the curve changes its direction. I have picked 3 x-axis test values in this curve section, which are 3, 5 and 7. Their corresponding y-axis values are 2. 3.25 and 4.5. The first thing that stands out is that all y values are lower than their x-axis counterparts. This means that the gradient of this curve part is below 1. Also, the ratio between them always stays the same, which is around 0.65. If you multiply 5 with 0.65, you get 3.25. The same applies to 3 or 7 with their respective y-axis values. Similar to the curve from before, this means that in this section of the curve, the mouse sensitivity is affected by the curve. The difference this time though is that the mouse sensitivity is not increased but reduced by 0.65. When I move the mouse with 50% speed on the mousepad, the in-game crosshair doesn't move with 50% speed too but only with 32.5%. Since the ratio of 0.65 always stays the same in the first section of the curve, there is no acceleration on your mouse movements when moving the mouse with a speed of 0 to 70% on your mousepad. This will change in the next section of the curve though. Once again, I have picked 3 test points. Here you can see the results. An important difference now is that the x to y value ratio is no longer the same between the 3 points. This means that aiming with the mouse will no longer be linear, or so-called 1-to-1 as known from the PC. The ratio between 8 and 6.3 is 0.79, while the ratio between 9 and 8.1 is already 0.89. As a result, when the mouse is moved with a speed of 70% up to 100% on the mousepad, the crosshair in the game will accelerate from 45% to 100%, which is the maximum turn speed of the game. Also, the gradient of the curve switched from below 1 to above 1. So, what is the conclusion of this curve? Well, in its first part the curve will reduce my mouse sensitivity by 0.65. Since the gradient doesn't change, I will not experience any acceleration. In the second half of the curve there is a lot of acceleration. Overall this curve will allow me to make slow and precise mouse movements with up to 70% mouse movement speed on the mousepad with linear scaling. The second part of the curve makes sure that I also have the option for a very fast turning speed, thanks to the acceleration. The only downside is that in the second part of the curve the ratio no longer stays the same but changes, and therefore my aim will not be linear anymore. This can make it difficult to build up muscle memory or make precise turns. However, the advantage of this curve is that I can precisely aim with a reduced mouse sensitivity while keeping a very fast turn speed to quickly turn around in game. Before I will recap and summarize the concept of the ballistic curve, and what you should look out for to understand a curve without having to compare a lot of x and y values, let's look at a very special ballistic curve first. This curve is basically a horizontal line. It looks very strange, right? Now let's try to solve this together to test your new ballistic curve skills. The first thing we should do is to pick a test point. Since the curve doesn't change its direction at all, we can pick any x value we want. I will go with the x value of 3 again, and move vertically up from there. The y value I receive when moving horizontally to the left is 5. When I do this with the x value of 7 again, I also get the y value 5. This applies to any other x value too. No matter which one I pick, its y value will always be 5. But what does this curve do? Did you figure it out already? You can pause the video here if you would like to think about it. The answer is that no matter with what speed you move your mouse on the mousepad, slow, medium or fast, your crosshair will always move with 50% speed in the game. This obviously is not a very good curve at all, but it is a great example to understand curves in general. Now let's recap and summarize. For this we will use the following curve. The first thing you should do when analyzing a curve is to find out how many sections it has. This curve changes its direction 2 times, so we have 3 parts to look at. Alternatively, look at the gradient of the curve. As soon as it changes you have a new section to look at. So how can you quickly tell what a curve section does without having to compare a lot of x and y values? The best way for this is to look at the gradient of the curve sections. When the gradient is above 1, or in other words steeper than the linear default curve, you have positive acceleration. The curve section 2 is a good example for this. When the gradient is exactly 1, which means the graph section is parallel to the linear default curve, you have no acceleration at all. If the gradient is below 1, as in the graph is flatter than the linear default curve, then you have negative acceleration. Section 1 and 3 of this curve are for example flatter than the default curve. There is one exception though, which is when the graph starts in the bottom left of the ballistic curve. When a graph is straight and starts in the origin, you will have no acceleration until the curve is changing its direction. A graph steeper than the linear default curve will upscale your mouse sensitivity. A graph flatter than the linear default curve will downscale your mouse sensitivity. When the graph is identical to the linear default curve, then nothing is happening at all. So let's do a quick analysis of the curve. In the first section, the graph is flatter than the default curve, which means that we have negative acceleration. But since the section starts in the origin and is a straight line, all it does is to reduce our mouse sensitivity and no negative acceleration is affecting our mouse movements. Our mouse movements will be slow and linear. In the second part of the curve, the graph is steeper than the default curve, so we have positive acceleration. The steeper it is, the more acceleration is added. In the third part of the curve we have a flat graph once again. It has the same gradient and slope as the first curve section. This means that their negative acceleration is identical. However, this time we are not directly connected to the origin, so we actually have negative acceleration on our mouse movements. The third section therefore basically stretches out the last few percent of the game's maximum turn speed. This makes it much easier to turn very close to the maximum turn speed of the game, as it becomes less likely to move the mouse faster than the game allows us to turn. In the second part of the video, I will analyze a lot of popular ballistic curves that can help you to increase your gaming performance. I will also explain a few more curve scenarios that I haven't covered in this video yet, such as exponential curves or vertical curves. If you have any questions about the XIM, or about the ballistic curve, just ask in the comments down below. If you liked this video, hit the like button or even subscribe to this channel. Also, let me know if you would like to see more of these tutorials in the comments down below, and I will maybe see you in the next one. Until then, enjoy your XIM experience.